morning to all. Myself Eshank Jain, Assistant Professor in CSE Department. Today, now I'm discuss the introduction about the compiler design that is run on 6th semester in AKTU curriculum. First of all, introduction. What is compiler? Compiler is a translator that converts the source program written in high level language and convert into the target or executable program, or we can say that in low level language, that is called compiler. This is a block architecture of compiler in which this is high level language and this is low level language and this is compiler, means this is translator that convert the high level language into the low level language. Next is, what is high level language? That is C, C++, Java, and low level language is assembly language and machine level language, that known as 0 or only 1. Now we have to describe in depth what is high level language. High level language is that understood by human. This is also known as source code. Generally, the high level language is written by any human person, or that is known as source code. Next is 0 and 1 in binary called machine code. The machine understand only the 0 and 1 binary format, so it is known as machine code. That is also known as target code. Target code. Now, the source code into the machine code, we use either a compiler or an interpreter. So both are the translators that convert the high level language into the machine level language. Both compiler and translator are used to convert a program written in high level language into machine level code. Now, this is the difference between interpreter and compiler. Interpreter translate the statement one by one, and the compiler scan the entire program at a time and generate the machine code of the entire program. Interpret take less amount of time to analyze the source code. Compiler analyze the source code with large amount of time. The third one is no object code is generated. There is generate object code. The programming languages like JavaScript, Python, Ruby is generally translated by the interpreter, and C, C++, and Java that are known as high level language, in which we use compiler to generate the target code for any specific language like C and C++. This is the simple structure that we have already discussed. The process of compilation in 2 phases. Number 1, source program, that is the analysis part, and second one is the synthesis part. This is also known as the front end, and this is also known as back end. This is target program and this is the source. Now, the phases of the compiler. These are the phases of the compilers that generally the source program go through these phases and generate the target program. Number 1 is source program, is also known as high level language. Then the lexical analyzer, semantic analyzer, intermediate code generation, code optimization, and target code generation, and last at target program. These are the 2 additional phases known as symbol table management and error handler. Now we have to discuss one by one these phases. Suppose this is the statement P equal to I plus R into 40. This statement will go through all the phases and generate the output of each phases. The lexical analyzer that convert the find out tokens. Tokens is also known as the smallest unit of the program. This is known as tokens. So lexical analyzer find out the tokens. The tokens include such as lexeme, identifiers, constants, variables. These are known as the tokens that is generated by the lexical analyzer. So in this statement, we have three variables P, I and R that pass through the lexical analyzer phase and generate identifiers, three identifiers, and this is constant value. Now syntax analyzer. Syntax analyzer generate the syntax tree of the program. Generally, the syntax analyzer generate the syntax tree of the program, or we can say that parse tree of the program. This is the parse tree for this particular statement. ID1 equal to ID2 plus ID3 and multiply with 40. So this is the parse tree of this particular statement. Next is the semantic analysis phase. Semantic analysis phase generate the meaning, the correct meaning of the source program. So semantic analyzer. This is called the semantic analyzer. It means integer to float. This is the main concept of semantic analyzer that generate the meaningful information from any statement. The intermediate code generation. This is the middle part. It will generate the intermediate code, or also known as the middle phase of the compilation process, in which we have generate the intermediate code of the program. This is the intermediate code of this particular statement. Next is code optimization. It is also known as the optional phase. Code optimization means we have to reduce the number of lines or some techniques in which the computation time of the entire process will be reduced due to some techniques and due to some code replacement policies like this, in which we T1 equal to ID3 into 40 and ID1 equal to ID2 plus T1. This is called optimization. Last one is target code. This is known as the final code of the entire program, in which we have used mnemonics, registers that generate the target program. Next, what is the passes of compiler? A compiler pass refers to the traversal of a program through the entire program is known as passes. Pass also refer to the group of phases into different modules, because in the last slide we have discussed the various phases of the compiler. So passes create different phases or different module according to the phases of the compiler, in which we have to merge two phases or three phases or the entire phases into one module. There are two types of compiler passes. single pass and two pass or multi-pass. In single pass, we have only one pass in which the entire program go through the pass and generate the output. In multi-pass, the source code or abstract syntax tree of a program multiple times. In multi-pass compiler, we divide the phases two or more module in which the compilation process divided into many phases or many modules. Single pass compiler, in which we can see that the whole phases are into one block, that is known as one pass compiler. We can see that. Next is two pass or multi pass, in which we can see that this is one pass in which there are four phases, and this is called second pass in which we have two phases, that is called front end and this is called back end. The front end is known as machine independent and back end is known as machine dependent code. Now, one pass, two pass, three pass compilers. To recap, what is bootstrapping? Bootstrapping, in which the translate more complicated program, which is turn may handle of many complicated program. Means in which suppose we have any source language and that is run on any machine that does not provide any output that is generated or that is required by the user. So we can run this type of language into another machine and generate the required output that is required by the user. That is known as bootstrapping. Language associated with a compiler, source language, target language in which the compiler generates the final code, and implemented language means the language in which the compiler itself is written is known. It is represented with the help of T diagram: source language, target language, and the implemented language. Now, what is cross compiler? The compiler which runs on one machine and generate target code for another machine is known as cross compiler, in which we can see that this is source language, this is target language, and this is the implemented language. Above compiler compile program written in language S on machine M, but will generate the target code for machine N. This is called implemented language, जिसमें हमारा कंपाइलर लिखा गया है. ये देखिए, इसमें create a compiler for language S on machine N by using a existing compiler for the same language on machine N. We can see that this is source language, this is target language, and this is the implemented language. So SSN. So SSN, we have used the similar type of implemented language for second machine, SMM. So he generate next this M will be used for this M, and a cross compilation is created. So we can see that this implemented language will be same for every compiler. So we can compile the program and generate the output according to the user with the help of cross compiler. Now we can see that another example. This language will be same for another language. Desired, this is the given, this is desired. So we can see that this language will be implemented. Same, and we can see that so we can easily understand that the concept of cross compilers. Now, what is finite automata? Finite automata means that is recognized to the pattern of any program, or generally implemented in lexical analysis phase. Finite automata means we have the n number of input and n number of output, and only take one input at a time and generate one output at a time. These are the 5 tuples: Q, sigma, Q naught, delta, and F. Where is Q? Set of non-empty states, finite of input alphabets, initial state, transition function, and a set of final states. These are the 5 tuples. There are 2 types of finite automata: deterministic and non-deterministic. In deterministic, one transition per input per state and no epsilon move. In non-deterministic, we have multiple transition state for one input and can have epsilon move. This is the deterministic finite automata. 5 tuples that we have discussed. This is the transition function that are vary in deterministic finite automata and non-deterministic finite automata. It means we can see that at Q naught A, Q naught B, Q1A, Q1B. So we can, this is the mapping. Q1A, this is the mapping of DFA. Mapping of DFA. One transition per unit. In non-deterministic, this is the important PQ, power set. Power set. So this is the power set of Q. 2 states, then 2 to the power 2, then 4 states. This is the mapping function. Representation of finite automata as its state transition diagram. As is the example, DFA of string ending with 0. So we have a string like 0, 1, 0, 0, 1, 0, 0. It is also accepted 1, 0, 1, 0, 0. This is the state transition diagram of any DFA. Representation in the 2D array form. This is the transition. This is the table diagram. In 2D array form. This is the 2D form of this particular transition diagram. We have seen that at Q naught we have input 0, then we have moved Q1. At 1 we have Q naught, Q1 at 0, Q1 and Q. This is the state transition diagram. Now what is regular expression? Regular expression is generally come in lexical analyzer phase. It is the representation of the pattern which is used to formulate token in a high level language program. Regular expression can be epsilon is also a regular expression, is also known as null move. epsilon को it is also represented null move. A, any input, is also a regular expression. Suppose R is a regular expression, then R star is a clean closure that include epsilon. R plus does not include epsilon. At most one occurrence. R plus S, R divided S is also a regular expression. R dot S, the concatenation, or this is the Thompson method for any particular regular expression. Epsilon ka, this is the regular expression. Epsilon is a regular expression that is called a NFA, Thompson construction. Only A, this diagram. R dot S, continuation form, and R plus S, the union form, and R regular. So in next video we have to discuss about more on regular expression.